Hello everyone. So today we are going to discuss some of the questions of electric charge and its basic properties. So as in today's class we have already discussed about electric charge, what is electric charge and its SI unit, and also different methods of charging a body, and also we have also discussed about the basic properties of charge. Okay, so let us solve some of the questions. The first question is, an electric shock is experienced on opening the door of a car. This is due to. Okay. So, this is simply due to the discharge of electric charges through our body. So, these charges, they get accumulated due to the friction between the cloth, our cloth, and the seat cover. These are the two insulated bodies. So, due to friction, the charge get accumulated on the seat cover, and when we open the door it get discharged through our body. That's why we experience an electric shock. So this happens sometimes, not often. This happens only in sometimes. Okay, the answer will be option B. Now let us move to the next question. The next question is, if a plastic rod is rubbed with fur made to touch two small pith balls suspended nearby, okay, then which figure shows their final configuration? Okay, so here you see, suppose here two pith balls are suspended from this point, and now when we rub a plastic rod with fur, then the plastic rod attains some charge. Due to the friction it attains some amount of charge. So when you will now bring the plastic rod in contact with these two pith balls, due to conduction, these pith balls will attain the same type of charge, that is, it will attain a positive charge. This pith ball will also attain a positive charge. Now, as we all know that like charges will repel, so these two pith balls are now going to repel each other. So their final configuration is somewhat going to be like this. So here also option B will be correct. Now let us move to the next question. So next question is soap bubble is given a negative charge. Suppose we have a soap bubble and it is given a negative charge. Then its radius will decrease or increase or remains unchanged, okay, or the data is insufficient. So let us see. Suppose this is a soap bubble. So when we give the soap bubble a negative charge, the negative charges, they get accumulated on the surface. Suppose this is the point A, this is point B. A and B are diametrically opposite points. So what will happen? They both will get repelled from each other. Similarly, suppose this is point C and this is point D. These are also diametrically opposite points, so they will also get repelled from each other. So as a result, what happens? The radius of the soap bubble will start to increase. Due to repulsion between the diametrically opposite points, the radius increases. So here the option will be B again. Okay, now let us move to the next question, question number 4. So question number 4 is, one metallic sphere A is given a positive charge, whereas another identical metallic sphere B of exactly same mass as that of A is given equal amount of negative charge. Then, okay, so you have to find whose mass is going to be greater here or smaller. So here you can see that suppose this is the metallic sphere A and this is the metallic sphere B. Both are of same mass, both are identical, it is given, and both are of same mass. But now the sphere A is given a positive charge, that means it has positive charge. What does it mean? It means it has a deficient of electrons. Electrons are less, okay, less electrons, and here negative charge is more, that means here more electrons will be there. So obviously, since in the B sphere more number of electrons are there, so mass of B will increase and mass of A will decrease. So from this we can say that the option D will be correct. Mass of B will increase. Okay. So now the next question. If two bodies are rubbed and one of them acquires a Q1 charge and another acquires a Q2 charge, then the ratio of Q1 is to Q2 is. So ratio of Q1 is to Q2, obviously when the two bodies are rubbed against each other, suppose this is the body A, this is the body B, when we rub against each other, one of them will attain positive charge whereas the other one will attain equal amount of negative charge. Suppose this is plus 5 coulomb, then this will be minus 5 coulomb, so the ratio is going to be minus 1 is to 1. Option C will be correct. Okay, now the next question. In general, metallic ropes are suspended in the carriers to the ground, which takes inflammable materials. The reason is, okay, again the same type of question like the question number 1. In case of inflammable material carriers, due to friction with the dry air and dust particles, it attains some amount of static charge. Since there are highly flammable materials, so there is a much chance of a spark and it may cause fire. So to avoid this, to keep the body, the option will be C, to keep the body of the carrier in contact with the earth, so that as soon as the charge gets developed, it will immediately transfer to the ground and there will be no chance that there will be some spark. Okay, next question. In charging the body by induction, okay, in charging a body by induction, the body must be an insulator, the body must be an semiconductor, body must be charged, must be a conductor. Yes, the option C will be correct here. Because for induction process, here you see, suppose here it is a sphere is there, so positive negative charges are present inside it. So when you bring a positive charge or a negative charge particularly, then what happens, all the positive charges will get aligned in one surface and all the negative charges will get aligned to other surface. So for this process to happen, the charges need to move from one place to other. So that is possible only in case of conductors, not in case of insulators. Okay, that's why the option C will be correct. Next question. When a glass rod is rubbed with silk cloth, the charge appears on both. This observation is consistent with the law of conservation of charge, as charge on both causes attraction, charge on both causes repulsion, charges appear on both bodies are equal and opposite. Yes, this option will be correct. Charges appearing on both the bodies are equal and opposite. That means the total charge remains conserved. Next question. Suppose charge on a metallic sphere is Q, and if the sphere is put in contact with an identical uncharged sphere, the charge will spread over the two spheres. by symmetry the charge on each sphere will be. So here you can see here one sphere is there whose charge is q, another sphere which is uncharged. So now when you are going to put the sphere charged sphere with the uncharged sphere, then both will get equally, the charge will get equally distributed between them, but they must be identical spheres. Okay, next. Okay, so next question, here you can see question, it is given that a body gives out 10 to the power 9 electrons per second. How much time is required to get a total charge of 1 coulomb from it? Okay, so how to solve this question? You can see here it is given that a body gives out 10 to the power 9 electrons. Okay, 10 to the power 9 electrons it gives in 1 second. So that means in 1 second how much charge does it give, we have to find. So in 1 second the charge is given is 10 to the power 10 to the power 9 into 1.6 into 10 to the power minus 19 coulomb. Okay, but we need a charge of 1 coulomb. So for that how much time is required? So for 1 coulomb it is going to be 1 by 10 to the power 9 into 1.6 into 10 to the power minus 19. So it will be 6.25 into 10 to the power 9 seconds. So which is going to be approximately 198 years. Okay, so next question, the number of electrons that must be removed from an electrically neutral silver dollar to give it a charge of plus 2.4. Okay, so number of electrons it is asked, you can simply use the formula Q is equal to N into E. So Q is given 2.4, N is required, charge of electron is 1.6 into 10 to the minus 19. On solving this you can directly find 2.4 into 2.4 by 1.6 into 10 to the power minus 19, which is going to be how much? 1.5 into 10 to the power 19 electrons. Okay, now the next question, last question. An object of mass 1 kg contains 4 into 10 to the power 20 atoms. Okay, so in 1 kg the number of atoms is 4 into 10 to the power 20. 4 into 10 to 20 atoms are there. So if one electron is removed from every atom of the solid, the charge gained by the solid of 1 gram is. Okay, so here you see in 1 gram we will find out how many atoms are there first. So 4 into 10 to the power 20 by 10 to the power 3 atoms will be there in 1 gram. So that equal to how much? 4 into 10 to the power 17 atoms. From these atoms, this much atom you will find, you will take out one electron from each atom. That means number of electron which will be removed will be how much? That will be 4 into 10 to the power 17, and charge of one electron will be 1.6 into 10 to the power minus 19. So final answer on calculating you will find it as 6.4 into 10 to the power minus 2 coulomb. So option B will be correct.